Objects and classes. By the end of this video, you should have a sense of the difference between procedural programming and object-oriented programming. You should understand the differences between objects and classes, understand the differences between classes built into the .NET framework and custom classes that you build yourself, have a sense of when it's a good idea to build your own custom classes, know how to create a class and use it in a program, and you should know how to use region statements to better organize the code in your class. Let's start by talking about the differences between procedural versus object-oriented programming. There are a couple of programming paradigms, and this paradigm is the sort of overreaching, predominant way of going about a particular task, in this case programming. Procedural programming, the rationale when it was developed was to make programs easier to implement than they were in assembly language, which is what came before them. It was a predominant style of programming in the 1960s all the way up through the 1980s. Some of the programming languages that implement the procedural programming style are C, COBOL, Fortran, and BASIC. Procedural programming is basically defined by a list of instructions. A procedure, in other words, an algorithm, or is something to be stepped through one by one. That worked relatively well for the programs that were built in the 60s and 70s when software wasn't quite so complex. But then into the 80s, when things began to get really large, we began to see GUI interfaces. We saw the first, Windows computers, things with mice that could, control things on the screen. Programs became more and more complex, and it was very difficult for programmers to keep track of a very long procedure like what was used in a procedural programming. And so they went searching for another way to do this, and they came up with this idea for object-oriented programming. So the evolution from procedural to object-oriented, and before that from assembly to procedural, is driven by the need to make programs easier to design, build, and maintain, and in the case of object-oriented programming, to encourage code reuse, because one of the things that they realized in the procedural era was that they frequently did the same things over and over again in different programs, and they thought, wouldn't it be nice if we had sort of a library of code that we could go back to and use whenever we needed to. And so the object-oriented programming paradigm sort of played right into that and went to great lengths to try to make their code reusable. Object-oriented programming began again in the 1980s, and it is still the dominant paradigm today. Programming languages like Java, C#, C++, Visual Basic, PHP, Ruby, Python, pretty much any of the modern languages that are in use today, if they are not explicitly oriented from the ground up when they were designed, they support an object-oriented style of programming. So object-oriented programming is currently the dominant paradigm for building software, so it's very important that you try to understand it as part of this class. Okay, so let's begin to talk about object-oriented programming. The core element of object-oriented programming is the object. But we talk about objects and we talk about classes, and the terms sometimes get used interchangeably, jumbled up, but they actually have a fairly specific distinction, which is an object is a concrete instantiation of a class. So if you think about a class as automobile, then an object might be 2010 Honda Accord, right? A very specific car. You might even go so specific as to say, the 2010 Honda Accord with the VIN number, X312458738, right? An object is a very specific instance of a class. A class is a general case of a particular object. So automobile would be the class, and then you would have, Honda Accord as the object, the concrete instantiation of the class. Now, you might have a couple of levels in between that. So the class automobile might be subdivided into several child classes like truck, sedan, sports car, things like that. So each one of those child classes inherits some of the properties of the parent class, which would be automobile, and in turn those child classes each implement something specific. So a truck is going to have, payload and bed size and things like that, whereas a sedan is going to have different properties associated with it. So that's the concept of classes and object. Classes are this sort of generic description of a type of object, and object is the concrete instantiation of that idea. When you actually write a program, a class ends up being a block of code that defines all the properties that an object can have. I'd like to refer to this as the nouns, and also defines all the things that the object can do, and I like to refer to that as the verbs. So classes is code, has a block of code that has defines properties, and it defines methods, or the verbs. Classes are typically defined in their own file. In other words, you have one class per file. And every time you create a new variable or constant, it is an object which instantiates some class. So even if it's an integer or a double or a string, one of the basic core variable types, data types, those instantiate the integer, the integer class, or the double class, or the string class. Likewise, buttons, text boxes, all of those things are concrete instantiations. They are objects which instantiate some abstract class which defines all the properties and the methods associated with a text box or an integer or string or a button or anything like that. So we frequently refer to the objects class as its data type. Okay, so what is this thing called the .NET framework? Microsoft's .NET framework is a very large collection of classes that have been built to make writing software easier. One of the things that people who are new to Visual Basic and to the .NET framework get confused about easily is that the .NET framework is a series of classes, and Visual Basic is a programming language. Although Visual Basic .NET uses the .NET framework, the .NET framework itself is not Visual Basic. In fact, all the classes that you use in VB.NET can be used in any language that has access to the .NET framework, such as C#.NET, Visual C++, J#, etc. You can follow the link on the slide to see a comprehensive list of languages that have been ported into to be able to use the .NET framework, and it's actually quite a long list. So you can still make use of the .NET framework to write Windows programs or other things like that, and also still program in a language that you're familiar with. If you're don't happen to be friends with Visual Basic, maybe you want to use J# or something like that. So here's an example of two blocks of code that are functionally equivalent. One is written in C# and one is written in VB. On the left, we see the syntax used in C# to declare a variable, a string variable. We call this string hello, and we give it the initial value hello with an exclamation point, and then we display that in a message box. On the right hand side, you see a block of Visual Basic code. Again, we declare a variable str hello as string data type, and we give it the initial value hello with an exclamation point, and then we display that message in a message box. So I want you to notice the differences and the similarities between these two blocks of code. First of all, the difference between C# and Visual Basic is syntactic. The syntax is different. So the way that you declare a variable in C# is to start with its data type, then the variable name, and then if you want to give it a value, you have an equal sign and the value assigned to it, and every line in C# ends with a semicolon. In Visual Basic, when we declare a variable, we use the dim statement to indicate that we're declaring a variable, then the variable name, then the as keyword, and then the data type. Finally, we would end with an equal sign and the value we're giving to the variable and no semicolon. Right? So in both of those lines, we've declared a variable. The only thing that's different between them is the syntax, and that is going to be different from language to language, and that's one of the things you have to learn when you're learning a new programming language. But now let's look at the second line. in both of them, other than the semicolon, the text is exactly the same, and that's because the message box class, which is a part of the .NET framework, is available to both C# and to Visual Basic, both of which are .NET languages. So once you learn the .NET, you need to learn that the .NET framework is not the same thing as Visual Basic. It's not the same as C#. Those are programming languages that make use of this common framework for writing applications for Windows. And so that's an important distinction to wrap your brain around as you move forward. It also should make it not so scary if you want to, for example, try to learn C# alongside of VB.NET, or after you get comfortable with VB, move on to C#. A lot of the functions that you'll use will be familiar because they'll be from the .NET language. All you need to learn is a new form of syntax. So just to give you sort of a thumbnail sketch here, the .NET framework is huge. It comprises hundreds of classes, all of which can be used in your programs. And so you think, oh my gosh, how do I learn this? First of all, relax. It's not necessary to master the entire .NET framework. In fact, most people who use it have only used a very small subset of what it offers, and most programs that you write only will use a very small subset. In fact, and also a lot of what you build is automatically generated for you when you build your project. And remember that thing I said about how programmers spend about 90% of their time being stuck on some problem before going to the next one? A lot of that time is in fact spent trying to locate, understand, and make use of some part of the .NET framework. I'll talk a little bit more about that right now. So this is a good procedure to keep in your head. This locate, understand, use. These are the steps for making progress in your program if you want to make use of the .NET framework, or if you're doing Java and you want to make use of the Java API or any other sort of API. API stands for Application Programming Interface. The .NET framework is an API. Most programming languages for Windows environments have some sort of API that you can make use of. When you want to make use of those functions, here are some steps you can follow. The first step is to locate the classes that you'd like to use in your program. This is probably the hardest step, but a good rule of thumb is to trust your gut. If you want it, chances are somebody else has wanted it too. That means that some .NET class exists to do it, it being the thing that you're trying to get done. So for example, in the program we're going to write later on in this video, I wanted to find out what the currency symbol was, like a $sign or the yen sign or the euro symbol. I wanted to figure out what those symbols were for each of the currencies for a currency converter. And I suspected that somewhere buried in the .NET framework was a way to get those symbols, but I didn't know how to do it. And so I'm going to demonstrate how to go about figuring out those things in the video later on when we do the programming demonstration. In general, when you're trying to locate a class to use for your program, terminology is the biggest obstacle. The names that the programmers at Microsoft and at Sun, where Java is developed, that they give to the classes that they put into their APIs, into their frameworks, are not intuitive to people who have not been programming for a while. Although they make sense once you learn them, there's really no way to guess ahead of time what they're called. And so, the majority of our time that's spent, trying to make use of the .NET framework is actually doing Google searches or doing searches in the documentation to figure out, is there a class that does what we want, and what the heck is it called? So what you should do, in general, start with plain English. Go to Google, type in a question like, how do I change the size of a box, right? How do I change the size of a text box? Type your question in English, and chances are someone else out there will have asked a question very similar to yours using very similar words, and they'll have done it in forums and places like that. And once you go into those forums, you'll get clues as to what the actual correct words, the names of the classes in the .NET framework are that you'll want to use. Maybe you won't hit on it right away. Maybe it'll take a few minutes, maybe half an hour. Maybe you'll give up in frustration after 45 minutes. That's happened to me as well. But what should happen is you should gradually refine your search queries to triangulate what it is that you want to do. Just be patient at it, and I promise you, you'll get it eventually. So once you've figured out what the name of the class is that you want to use, the next step is to understand it, to understand what it does, what properties it has, what methods it has available to it, and to then go about figuring that out. So the way you do that is you read the documentation. Read it carefully. You look at the example code. The MSDN library, where all of this stuff is written down, frequently has examples along with all of the elements of code, so you can read the stuff there. You can also find other people's example code in forums, on their websites and blogs and places like that, and frequently looking at how somebody else did it will give you the key to how to use it correctly yourself. And finally, the use phase. You want to try out this class library, use this functionality in your own program. Sometimes if it's sort of complex and your program is already pretty big and it already does a bunch of other things, you may want to stop the program you're working on, start a completely new program that's small and exists for one single purpose, which is to try out this new class so that you can figure out how to use it all by itself in an isolated and sort of artificial environment. Once you've done that, then you can go back to the program that you start out with and use it there. Okay, so what do you do when the .NET framework doesn't do what you need it to? This is going to happen when the class you need is specific to a particular problem that you're solving. So, in the example we're going to do later, the currency converter, we're going to build a currency class because there's not one in the .NET framework, at least that I found, that does exactly what we want it to do. The other case when you might need to write your own custom classes is there is a class in the .NET framework that's pretty close to what you want it to do, but it doesn't do everything that you want to do, and so you're going to want to write your own class. You have a couple of options for that. You can start from scratch. That's what we're going to do in this video, or you can extend a .NET class, or you can extend one of your own classes. That's a more advanced way to do things. I'm not going to cover it in this video, but if enough people are interested in it, I might could cover it in a future video. Okay, so how do you build a class from scratch? Let's start out by looking at the parts of a class. As I said before, a class has two basic elements: properties, which are the nouns. These are the things that a class has. Properties have multiple types. There are private properties. Private properties are used only by the internal class operations, and so they're not available to other parts of your program outside of the class. You have protected properties, which are kind of like private properties, but child classes, classes that extend the class that you're building, can have access to them. You have shared properties. Shared properties is a kind of weird concept to wrap your brain around if you haven't been doing object-oriented development for a while. But they're kind of like private properties because they're only usable inside of the class, but the programming environment only creates one instance of the shared property, and all of the instances, all of the objects or variables that you create that are instances of that class share that property. Usually it's for some sort of static value that is not going to change depending on which instantiation of the class you use. I'll have an example of that in the video later on. And then finally you have public properties, and these are the properties that are of interest to the context where the class is used. So in other words, in your main program, when you create an instance or an object of your class, you'll be able to access and set these public properties so that your program can use them. Okay, so those are all the types of properties. Now let's look at the methods. These are the verbs. These are the things that your class can do. In VB.NET, these are also known as subs and functions, sub-procedures and functions. Okay, so the first special class of methods are called constructors. These are sub-procedures that begin with the new keyword. And new basically indicates that you're constructing a new instance of the class. That's what new means. That's what a constructor does. Constructors exist in pretty much every object-oriented programming language. They are a standard feature of classes, and they're one of the methods that we'll need to implement in our class. You have private methods. Similar to private properties, private methods are only used by internal class operations. We won't have one of these in the program we build later. Protected methods, similar to private methods, but the child classes can use them. We probably won't see these in this video either. Overridden methods. These are methods that are inherited from a parent class but modified in your own class. We're going to have one of these. We're going to override the toString method to control how our instances of our class get converted into strings in the program. And finally, there are public methods, and these are the ones that you use in your actual program after you create instances of your class. If you're a little bit confused here, don't panic. We're going to have an example in a few minutes, and you can always come back and review this part of the lecture after you've watched the video, and I think it'll really help it sink in and make a lot more sense. Okay, so let's get into planning and documentation. We're going to use, for example here, the currency class that we're getting ready to build in the program that we're about to develop. So for classes, you're going to start on paper, just like you did for your programs. Jotting things down on paper is a pretty fast way to do it. Naming your class is important. You want to try to use names that correspond to things that you know and understand. That's the beauty of object-oriented programming is if you choose object names that are meaningful to you, it will make it easier for you to solve the problem that you're doing. And there's a standard format for class diagrams. So they look like this. Basically, it's a table with a single column and 3 cells. In the top cell, you have the name of your class. So in this case, I'm doing the currency class. In the second cell, you have your properties. The little plus sign next to the property indicates that it's a public property, and the little minus sign next to it indicates that is a private property. So for our currency class, we are going to have a name property, a code property, and you can see that I've put the data type for those. They're both strings. The name is the name of the currency. The code is the 3-letter ISO currency code that's associated with that currency. And then we're also going to have the culture. Now, when I was thinking about this currency class, originally I put country in here for each currency, but then I realized there's some currencies like the euro that get used in many different countries, and so it's it's actually a culture-specific way to do this. And as I started digging around in the .NET framework, it turns out that the culture info class, which you see here as the data type for my culture property, actually has all of the information that I need to display a currency in with a correct symbol and all those things like that. And you'll see how that works in the program. Next, I have 2 private properties. One of the things I also realized about my currency class is that for me to convert one currency into another, I'm going to have to get up-to-date exchange rates. What better place to get exchange rates than the World Wide Web? So I went out on the web and I started looking for data services, web services that would provide me with the exchange rate information that I need, and I found this company called Mondor Software that has a fairly inexpensive currency web service that I decided to use for this application. In order to use the web service, I also have to have an API key. This is basically like a password that allows me to have access to their web service. So I also put that as one of my private member variables, one of my properties for my currency class. Okay, so down to the methods section, the third cell in this class diagram, I have 3 methods. They're all public, indicated by their plus signs. The new method, which is our constructor, we're going to take a value that's returned by the Mondor currency web service, and we're going to turn that into a local currency value, as indicated there. So you can see that the parameter inside the parentheses there is the is the Mondor currency coming from the web service, and the return type there on the right is an object of type currency. Then we've got the toString method, which we're overriding from its parent class, and it's going to return a string. And then we've got the convert method. It looks like I forgot to put the parameters here, but the convert method is going to need an amount of currency to convert, and also need a target currency to convert to. And the return type for this is going to be a double, representing the numeric value of the currency that was converted. The next step of documentation is to do flowcharts. You should do one flowchart per method in your class. In this class we have three methods. We have the new method, which is the constructor, which creates a new instance of our class. We have the toString method, which returns a string representation of our class. And then we have the convert method, which you can see I put the parameters in this case, amount and target currency. The convert method, which converts some amount of money into a target currency of another type. So if you follow the flowcharts down from the top with our new constructor, we need to get the Mondor currency from the web, and then we'll use that to assign the name for our currency, the ISO currency code, and also to figure out which culture that currency belongs to, and then we will end our procedure. For our toString method, we're simply going to return the name of the currency, and for our convert method, we need to get first to get the amount and target currency to be used. Then we're going to use our web service to convert those, and then we're going to return the converted amount as a double. And so those are our three methods that we're going to implement. Okay, so let's do it. It's time to dive into this programming project and walk through building our currency converter. We're going to implement a currency class as a part of that, and some other considerations are that we need to get our exchange rate data from the web, and we also need to figure out how to format our currency in the local culture that it comes from, and we can use the .NET framework for this. I want to show you how to figure that out. Alright, so here we are, and this is the beginning of my currency converter. I created a form, and I put some labels. I put a couple of drop-down boxes on here for having a source currency, a target currency, a text box where people can type in the amount they want to convert, a button to convert, and then a text box to display the result. Let's go and take a look at the skeleton code of my form so far. So this is a, you can see public class form currency converter, and one of the things you should notice, since we've been talking about objects and classes, is that the form is itself its own class. We are extending the Windows Forms class to create a specific class that handles our project, even though we don't normally talk about that. Anyway, here is the form load event, and when the program loads up, that's when we need to get the list of currencies that we want to show up in our form. So we're going to get the currencies from our web service. I think that's what we decided. And then we're going to create a list of currencies for our drop-downs. We're going to populate the list with the currencies retrieved from the web, and then we're going to add our list of currencies to the combo boxes. So that's sort of the list of steps that I've written out for myself, starting out with just sort of pseudocode and documentation. I've also need to handle what happens when they click the convert button. It's going to output a formatted currency value to the results text box. And the steps I'm going to follow when I do that, first I'm going to declare variables for the currencies, the amount that they want to convert, and the result that's going to get output. And then I'm going to get the amount that's got to be converted. If they didn't enter anything in that text box, then I need to say that no amount was entered. But if they did, then I need to try to convert that to double. And then if it fails the conversion, then I need to tell them that and provide them a way to get back from that. Finally, I want to get the result and output it with the correct symbol in the results text box. Alright, so we already decided we're going to implement a class for this, but we need to do a little bit of research here because we want to get our information from the web, And so I'm just going to try to recreate for you the sort of search process that I went through to do this. I actually spent probably an hour or maybe more doing some research before I finally made the decision about which web service to use. So let's switch over to Google. And so the first search I put in was currency exchange rates web service, and I got a bunch of things here. The first thing that I thought looked promising was this New York Federal Reserve Board.org website. The Federal Reserve, the New York Fed, is, as you may know, associated with our government. They set the amount of currency that exists in our country, and it turns out that they have a web service. Great. It's probably public and freely available. I did a little more digging here. It turns out they discontinued this service in 2008. Maybe they decided it was too expensive, or maybe they had some people telling them that they were cutting into their profits. Why do I say that? Because the next one I looked at was this Xignite.com website. This is the Forex web service operations website, and there's on-demand financial market data, right? So they have some web services here, things like listing currencies. That looks good. Get real-time cross-rate data, a whole bunch of interesting stuff that you can do here. And I went to do that, and they wanted me to sign up for a free trial. I was a little bit leery about that. How much would it cost to just buy their product outright? So I went to buy online. It turns out that if you want to pay for their service, that it will cost you a pretty penny. In fact, if your monthly maximum hits is only 600 hits, your annual fee is $600 or $639 if you pay now. I didn't want to pay $600 to do this little demo, so I went back and did another search. This time I looked for free currency exchange rates web service, and the first one that came up was this Mondor.org currency exchange rate XML web service. So I went to the Mondor website and I took a look at their service. Theirs is also not free, but it's a lot more reasonable. You can get a monthly subscription, which will allow you to have up to 100 requests per day, and that costs $2.70. You could, another one that I thought was fairly reasonable was this 10,000 requests with no time limit, and that was $40. But then I scrolled down and I found out that you can get a demo key that will last for 14 days. And so that's what I did. I ended up requesting a demo key. They emailed it to me right away, and I was able to get up and running. So the next thing to do for me was to go to their user manual, which is here in this tab, and it's fairly simple. It's basically 2 pages. I started looking at it, and they've got code here that's written in C#. I was like, well, I can recognize that. That's a .NET language, and they talked about how to use it. And they basically showed you how to convert it in basically 3 lines of code. I know this looks like more, but the lines have wrapped in here. So I decided to go with this service. All right. So the next thing I'm going to show you is how you set up a web service that uses the WSDL, the Web Services Description Language, in Visual Studio. So you need to get the URL here. Go back into Visual Studio. Go to my Solution Explorer. I'm going to right-click on my project name and add service reference. So service references allow you to add web services into your .NET program very easily. So I just paste the URL in here, click Go, and it will go out to the web and find the rates web service. And if I click on that, I can get some more information about all of the different methods that are available. So here's one, convert, and there's another one, get currency codes. There's another one, get currency list. These are the methods that I'm going to be able to use to get the data to populate my program. So I want to add this reference, and so I should give it a namespace. In this case, I'm going to start with WS, which stands in this case for web service, and I'll call it Mondor currency rates. and click OK. You can come up with any name that you want to here, by the way. This one I chose because it would remind me what this is. Okay, you can see that once I've imported the service, in my Solution Explorer now I have a new folder that says Service References, and it's got my WS Mondor Currency Rates service that I just imported here. It also has added an app.config file. That basically contains the URL and the other information that the program will need to be able to make use of this web service. So let's begin in our main program here, in our main form, and we can begin by figuring out how to get the currencies from the web service. So I'm going to declare a variable to be able to get the rates from the web service. So let's the first thing to do is I need a variable that will give me access to the web service itself. So I'm going to call this WS for web service, rates client. We typically call web service clients clients, right? So I'm going to call it rates client as new WS, and you see when I type WS, Mondor Currency Rates comes up because that's been imported into my program. I can hit Tab and hit a dot, and then I want to get the rates SOAP client. Basically that will create an object, an instantiation of the rates SOAP client class that I can use to query the web service. Next thing I'm going to do is actually query the web service, and so I'm going to create a variable here. I'm going to call it use MCR for Mondor Currency Rates, and I'm going to call it rates, and it's going to be a list. I wanted to get it as a list of WS Mondor Currency Rates currency objects. So the by inspecting what's available in this web service, I was able to determine that they have a class called currency, and that's what we want to get a list of. And we're going to set that equal to WS rates client, so we're going to use the client that we created on the line before this, and there is a function called get currency list that we're going to use. That returns an array of currencies, but what we want is a list, so I'm going to convert that array into a list. Alright, so with these two lines, what we've done is we have created an object which is an instance of the rates SOAP client class, and that provides us access to the web service. And then we created another object, the MCR rates object, which is a list. It's an object which instantiates the list class, and it's a list of WS Mondor Currency Rates currency objects, and we populated that list with the results of the get currency list method that is a member of the WS Rates client class, the rates SOAP client class, converted that into a list, and so now we're ready to create our list of drop downs. So I'm going to do that. I'm going to create another variable. It's going to be a list, so I'm going to start LST as its variable name, and it's going to be a list of currencies, and I need to say new list of. Now here I would like to turn this into a list of currency objects from my own custom currency class, but I haven't created that yet. So I'm going to stop here for a second. I'm going to delete this line, and I'll come back after I've created my own currency class. So to create my own class, I'm going to go to the Solution Explorer, right-click on my project name, go to the Add submenu, and then select Class. And so the Add New Item menu is going to come up. It's got class already highlighted. I need to give my class a name. In this case, I'm going to name it what it is, which is a currency, and click Add. And it's going to open up another file for me, which has the shell for my currency class. Now remember, earlier in the video I said A class is just a block of code which implements properties and methods. So let's start out by giving our class some documentation, and our currency class represents a world currency. That should be enough. Under here, under remarks, I'm going to put a remark in here that it relies on the Mondor Currency Exchange XML web service, and that can be found at http://www.mondor.org/cr.aspx. Alright, that will just remind me, if I ever come back here and want to work on this, where to find the website of the company that actually implemented this web service for me. Okay, so now I'm going to implement my currency class. Now, one of the things that I told you in the video earlier is that classes have a number of different elements. Basically, two big categories. One is properties; those are the things that the class has, and the methods, the things that the class does. And then I got more specific. I said they're private properties, public properties, and other things like that. In order to keep our code within our class organized, I'm going to show you a technique that this only applies to the Visual Studio environment, but you can use these things called regions. If you hit the pound sign and type region, and then you can give your region a name, for example, private properties, and then hit enter, it will create a collapsible region in our code, and that allows us to sort of collapse the parts that we're not interested in looking at right now. I'm going to go ahead and add one of these regions for each of the things that I need to create. Okay, now that I've created my 5 regions, we can begin to put stuff in them. Let's collapse the regions that I'm not going to be using right now, the ones below, while I work on my private properties region. Okay, so the first private property that I'm going to need is to provide access to the Mondor web service for currency info. And I'm also going to need to put in the API key. This is like a password that allows me to use the web service for accessing the web service. And then finally, one of the things that I realized as I was programming this was that I need to create some sort of object that has the list of 3-letter currency codes, the ISO standard currency codes that are used by all the world, that maps those to the different cultures where those currencies are used. The data type that I'm going to use for that is called a dictionary. And not only that, every instance of this class, the currency class, will use the same dictionary. This dictionary doesn't change from object to object. It's not something that needs to be set on an object-to-object basis, so I can create this as a shared dictionary. So I'm going to do that. I'm going to put a comment in here, a shared dictionary for mapping ISO currency codes to .NET cultures. And I'll talk to you more about cultures in a minute. Alright, so now that I've created those 3 comments, let's go ahead and put the properties in there. So the first, since these are all private properties, I'm going to use the private keyword. Private is like saying dim, so we're going to say private WS, and we need to give it a name, Mondor currency rates client. So this is a web service client, and as new WS Mondor currency rates subclient. So that's essentially the same line of code we had in our form class, but we're using that internally here in our currency class as well. The next thing we need is our API key. The API key will never change. It's a constant, so I'm going to declare it as a private const, right, for constant, and it's a string and API key using my naming convention all caps as string, string, and I need to give it a value, and I go to my email and I can copy that from my email and paste it back in here. That is my API key that they emailed to me, and I need to send that along with any requests that I make to the web service when I do conversions. Finally, I want to create my dictionary, which is private. In this case, it's shared, so I'm going to use the shared keyword. And dictionary, I'm going to use DCT as the three-letter prefix. Codes, it's mapping codes to cultures, so I'm going to call it DCT code cultures. And I'm declaring it as iDictionary of key value. Of key value, so the key is what you're going to use to look up a value in the dictionary. In this case, we're going to use the ISO currency codes, which are going to be strings. And the value we're going to look up is the culture info object. All right. So now when I mouse off of that, you see that culture info, this type is not defined, right? One of the ways we can get to it, though, it recognizes that the culture info class is part of the .NET system.globalization class. So I'm going to import that, and now you'll see at the top of my class it says imports system.globalization. Let's take a second to look at that in the .NET Framework library. So I'm going to switch to my web browser here and go to the MSDN library. And up here, if I want to find out more about the culture info class, I can by clicking and typing in culture info and culture info class system.globalization. Right, and here you can see the constructors, the properties, the methods that are associated with this class. You can collapse these if you like. Right, and remember I talked about all of these things in the video before. Every class has them, and you can learn about them in the MSDN library. You can also scroll down a bit and read a lot about Windows locales, read a lot about this stuff. I actually spent a fair amount of time reading this stuff, and then there are some examples of how you can use this code in a program. So I spent some time here, and I also spent some time online looking at some other stuff. I eventually found a snippet of code that someone had posted on Facebook to populate my dictionary, and I'll show you that code when we write it in a few minutes. Alright, so those are all of my private properties. So now I can close the private properties region and open up the public properties region and begin to type those in. Okay, so the three public properties that we're going to need are public, and we can name these public property name as string. And this will create a property that can be used outside of our class. So we'll create another one, public property code. That's for the three-letter currency code. And that's also a string. Oops. String. And then we also need to know the culture of the particular currency. And so we're going to have public property culture as, and this time it's a culture info object. All right, let's add some documentation to these. And so this one is the name of the currency, example given US dollars, and we will add some documentation for the code, which is an ISO currency code for the currency, e.g. USD, and then we'll add some documentation for the culture, which is formatting properties of currency, e.g. symbol like the $sign. Okay, so those are the three public properties that we need to declare for our class. And so now that we're done declaring public properties, we can close up this section and move on to the next section, which is constructors. We're actually going to write two constructors here. The first constructor we're going to use to populate our dictionary. So you remember, if we look up in the private properties here, we have this private shared dictionary called Code Cultures, which maps ISO currency code to .NET Cultures. If you have a shared property, the way to set it is using what's known as a shared constructor. So we're going to use the shared keyword, and we're going to call it sub, and all constructors in the in Visual Basic.NET are called new. You could put parameters in there if you wanted to, but for this one we don't need any parameters. So the first thing we're going to do is we're going to take our dictionary that we created in the private properties section, DCT Code Cultures, and we're going to assign it a value. We're going to we need to initialize it with the new keyword and set the data type to dictionary, and we have to provide the key and value types. We need to do it just like we did up above on line 17, and so it looks just like that. Alright, so here's the code that I borrowed from Facebook. So let me stop it a second here and put initialize our dictionary by using the new keyword to instantiate the dictionary class. Alright, so now we're going to get a list of cultures. Get a list of cultures supported by the .NET Framework. Turns out the .NET Framework provides you all the cultures you need, and so I'm going to create a variable here, and I'm going to call it cultures, and I'm going to set it as a list of culture info objects, and then I'm going to initialize its value by calling the culture info class. Has a method called getCultures, and that takes as its parameter the type of cultures that you want to get, and so I'm going to use the culture types class to get the installed Win32 cultures, and then I'm going to convert that returns an array of cultures. I'm going to convert that to a list because I like working with lists more than I like working with arrays. Alright, so there we go. Now I need to create a variable to keep track of the region. So there are two types of objects here. There's the culture info objects, and then there's another type of object called a region info object. This is also in the .NET Framework. They're linked together, but they're not the same thing. And unfortunately for us, the currency symbol that we're looking for is stored in the region info class, whereas the formatting properties that we need are stored in the culture info class. It took me a while to figure this out, but when I finally figured it out, it made sense. And so we need to create a variable dim region as region as an instance of the region info class, and we're going to use this in the loop we're about to write. So loop through the cultures. So we're going to go through all of the cultures in that are stored in the installed Win32 cultures, and to do that we're going to use a for each loop. For each. If you haven't covered looping yet, this is a good skill to have. This is one of these core competencies you should have for pretty much any programming language. Alright, so for each iteration of our loop, we're going to get one of the cultures from our list of cultures, and so I'm just going to I need a variable name for it, so I'm going to call it CI as culture info. That's what CI stands for. And I'm going to get it from the list of cultures that I created above. All right, so I'm going to loop through each one of those cultures up there, and then I'm going to try, I found out the hard way that this doesn't always work, I'm going to try to assign a value to my region variable as new region info, and the way you get the region info is by using the LCID property of the culture info class. If you don't understand what this means, don't sweat it. If you really want to get it, dive into the .NET framework, the MSDN library, and look up the region info class, and it's got a lot of information in there about it. Okay, so we first get a region, and then we try to add a new entry in our dictionary. So get our dictionary, and we will add an entry to the dictionary, and the first parameter is going to be the region dot ISO currency symbol. That is the key value. That's what we're going to be looking up, using to look up the culture info. And then the second parameter is the actual culture info object that is the current focus of this iteration of the loop. All right. I'm not going to put out any messages here in the catch block because I don't really need to. And so let's see. Let's put some. Go back and put some comments in here so we understand what we're doing. Try to assign a value to the region variable, and it turns out not all of the LCIDs in the installed Win32 cultures list correspond to a region, and so this doesn't always return a value. That's why we put it in try catch block. And then we're going to add the currency code for the region to the dictionary with its corresponding culture. All right, so that's what we're doing in this subprocedure. So let's go up and add some documentation for this subprocedure. And so it initializes the dictionary mapping ISO currency codes to .NET cultures. So that's what this subprocedure does. All right, so this is the shared subprocedure, and we use this to initialize the dictionary. This only happens once in the execution of our program, before any currency objects are created. And so this will allow for a more efficient lookup of culture info objects later on when we get to the output stage of our program. All right, so we need to add one more constructor. This is going to be a public sub new, and in this case we want to take one of the currencies that's returned from the web service and convert it into our local currency class type. So we're going to put a parameter in here, by val currency. We could even call it, why don't we do this, MCR currency, because it's coming from our Mondo currency rates object as ws Mondo currency rates dot currency, and we're going to use that to set all the values for our currency, all of our public properties. So let's go back up and take a look at what our public properties are. I'm going to close the private properties block, open the public properties block, and see we've got name, code, and culture. Those three things have to be set whenever a new instance of this class is created. So let's set the name equal to the MCR currency dot name. That will be returned from the web service, so we can assign it to the name property of the currency we're creating locally. The code is going to be equal to the MCR currency dot code, which is another property of the object that's returned. And you can see that when we imported our web service, it told Visual Studio about the types of objects that would be coming back from the web service, so they pop up in the IntelliSense there, and we're able to use them in our program. And the third thing we need to set is the culture, And for this, we're going to use our dictionary. So this is where our dictionary comes in handy. And the way we look up a value is to use its key. In this case, our dictionary's key is the 3-letter currency code. So we're going to use that to look that up. And once we've done that, we have finished with this method. So let's add some documentation here. And this creates a new currency object based on data from the Mondor Currency Web Service. All right. So we've finished our constructors. We'll have these two, one shared one, which sets up our dictionary, and then one that gets run for each instance of our new class and sets up all the properties for it when we run it in our program. All right, so I'm going to close the constructors region and move on to the overridden methods region. For this, if you went back to our class diagram, you would remember that we need to override the toString method so that when we use our class in a place where it needs a string representation, it'll output something useful. So we're going to put public overrides, right? When you put overrides, it tells Visual Studio that we are inheriting this method from its parent class. In this case, it's inheriting from system.object, which has this method toString. It tries to be helpful and write the method for us. We don't need this part. All we need to return is the name of the currency. And so we're just going to return the name property. Let's put a comment here. It outputs the name of the currency for its string representation. All right, so that's the only overridden method that we have to write. So let's close that, and then finally we can get to our public methods. Here we have only a single public method, and that is the public function convert, right? And this will take two parameters, by val dbl amount as double. That's the amount of the particular currency that we want to convert. And then we also need to know by val target currency as currency. We need to know the target currency for this, and the return type for this function is going to be double. It's going to return a numeric value that we can then output in our program. So in this case, we only have to write a single line of code. We're going to get the converted value from our web service, and so I'll type return and call our web service. We want the client, and it has a convert method, and the convert method requires a source currency code, and that's the currency to convert from. In this case, that would be the code property of the current class. So we can just put code there. Then it needs a target currency code, and we can get that from the target currency parameter that was passed in 2 lines up. So with target currency dot code, and then we need an amount, and that was also passed in as a parameter, dbl amount. And then the last thing that we need is the API key to send to the web service, or else it will not do the conversion for us. Right? So right now I'm using the free account, which will probably expire within the next few days. So if you download this code and you want to run it, you may need to go to the Mondor website and get your own API key, come in here and then paste that in up here in the private property section right here, so that you can use this program and see what it does. Alright, so let's go back and add some documentation for this method as well. This converts an amount into a target currency using the Mondor web service. Okay, and at this point we've now completed our custom currency class. All right, we have private properties, public properties, constructors, overridden methods, and public methods. Other classes might have other sections. You might have protected properties or protected methods, or even private methods that are only used within the class. These are the ones we needed in this case, and we've got them all nice and cleanly separated into these regions so that we want to come and look at them. We can look at the region that we're interested in without having other code around to clutter our vision. Alright, so I'm going to save that. Now we can come back to our currency converter form, and we can do what we were trying to do before, which is create the list of currencies for our drop-down. So I'm going to go in here, and I'm going to create a variable dim lst for list currencies, and to create a list of currencies as new list of. Now you can see that when I start typing CU, our currency class shows up, and you can see the documentation here on the right represents a world currency. That's from the documentation that we wrote when we created the class. Alright, so that creates our list variable. Now we want to populate that list from the currencies retrieved from the web. We're going to use that for each loop again like we did before within the class. So we're going to say for each, and we need to say that these are MCR rates as WS Mondor currency rates dot current. These are currency objects that come from the web service in MCR rates, which is the list of currency types that we got from the web service up here on line 15. Alright, so here's our for each loop. Every time, so we have a list of currencies that we've gotten from the web service, and this for each loop will loop through each of those currencies. Each time it goes through the loop, it'll assign that current currency to the MCR rate variable, and then we can add that to our list. So here's our list of currencies. It has an add method, and then inside of here we're going to use the new keyword to create a new currency object for this spot in the list, and we're going to use the method that we created, which expects an MCR currency. So we'll do MCR rate, which is the type we want, and then we're done. So we've now got a populated list of currencies, currency objects. These are objects of our local currency class, and they were created using the values we got from the remote web service. So now the last step of beginning our form is to add those values to the combo boxes. So we have two combo boxes. We have the source combo box and the target combo box. So I'm going to start with the source combo box. I'm going to take its list of items, and I'm going to add a range to that. Now the add range method allows us to submit an array of objects that will go into the list. So for that array, we're going to use our list of currencies, and then we'll use the toArray method to convert that list into an array. And then we'll do the exact same thing for the target list, items.addRange, LST currencies. Since it's exactly the same list that we want in both drop-down boxes, we'll do just like that. At this point, we've finished our list, our two list boxes. So just to go over that again, we get the currencies from the web service, and to do that we create a client, a SOAP client that can call the currency rates web service, and then we actually call the web service here and return that list of currencies that it gives us into this variable here, MCR rates. Then we create a list object for ourselves locally that's going to hold a list of our own currency class objects. And then finally we're going to take that list and use it to populate the two combo boxes that are on our form. Okay, so the last thing we have to do is to write the code to handle the click event when people actually click the convert button. The first thing we have to do is to declare variables for the source currency, the target currency, the amount of money to be converted, and a variable for the result. So let's do that. So let's do dim CUR for currency, source, this is our source currency, and we're going to use our currency type that we created. This is our class, and we're going to set that equal to the currency object that is currently selected in the source combo box. What we'd like to do is set that to cnbsource.selectedItem, but what you'll see is when I run my program, it's going to tell me that this selected item, it doesn't know that it's actually a currency, and it can't automatically convert it into one. So to make sure that it is what it is, we're going to use the ctype method here to convert that selected item into a currency object, just to be safe. All right, and we'll put a note here from combo box, and then we'll do the same thing for the target currency, dim CUR target as currency equals ctype CNB target dot selected item currency, and this is also from combo box. And then we'll create the two variables for our amount and our result. So dim dbl amount, dbl result as double, and we can put them both here on the same line since we're not assigning any values to them right now. Alright, so the first thing to do now is to get the amount to be converted. So we're going to check our txt amount text box, and if it is not null or white space, in other words, if they did indeed enter something here, then we're going to try to convert it into a double. So we'll say dbl amount equals cdbl, so that's convert to double, txt amount dot text. Oops, text. All right, that will attempt to convert that dbl amount into, or that text in the text box into a double. But in the case that they type something like a $, or other random characters or spaces that shouldn't have been there, then this conversion is going to fail. We know that ahead of time, so we are catching that exception, and we can put a message box in here that will tell them. Okay, so here I say please enter amounts as numeric values only. And that will put a pop-up. Then I clear the amount in the text box, and I put the cursor back there so that they can type it again. And then I have an else statement here which says no amount was entered, and you see this is what happens if this txt amount.text is null or white space, returns true. And so down here we're going to also put a message which says please enter a currency amount to be converted. Alright, so that handles getting the amount that needs to be converted. Now we need to get the result. So the first case I want to check for is that the amount that they entered is 0. If dbl amount equals 0, then we need to say, 0 was entered, and we don't actually have to do a conversion because 0 is 0 in any currency. So we can just say dbl result equals 0. That's pretty easy. The next thing I want to check for, I'm going to use an else if statement. I'm going to check to see if the source currency and the target currency are the same currency, because if you're converting from dollars to dollars, US dollars to US dollars, then there's really no conversion to happen. So I'm going to use cur source, and in this case I'm going to use the equals method, which is a member of every class, and see if that is equal to cur target. And if that's the case, then I'm going to say that the result is equal to the amount, because in this case, right, there's no conversion to do. And only if it's not 0 and they're not converting from the same currency to the same currency, then we can use our convert function. We're going to use the source currency convert function, and we're use that to convert the amount and into the target currency. All right, so let's put use currency class to convert amount into, from source currency into target currency. So that's what we're doing there. And so if all has gone well there, we should have a result. It'll either be 0 or the amount that they entered, or it hopefully will be the amount that was looked up on the web service. And the last step now is to do txt result dot txt text, right? That's the text value that's in the results text box. And we want to set that equal to the result converted to string. And the toString method on the double class allows us to convert it automatically into a currency formatted string by using the C parameter here. And then the second parameter it takes here is the target currency's culture. And so what this will do is, by submitting that target culture as the second parameter, it will actually add a $ or a euro symbol or a pound sign or a yen symbol or any of those symbols in the target currency that it needs to make it intelligible to the person who's using it. Okay, so normally when I would be building this, not on a video, I would have done lots of testing and lots of debugging and lots of other stuff in the meantime, but I wrote this once ahead of time to make sure that I would get it all right so I could do the video in as short a time as possible, and even with that, it's taken quite a while, I think. So let's run it and see if it works. Okay, well, crap. It looks like that even though I said I did all that testing when I was writing it the first time, I still managed to miss something, and found it right here. It turns out that before, I'm back in my currency class here, and you can see public sub new. This is where we create our new instances of our currency class as objects. So where we assign the name and the 3-letter currency code, and then we add the culture onto that as well. Well, it turns out that the cultures that Windows has pre-installed don't cover all of the currencies that are returned by our web service. And so it was going through the dictionary trying to find a culture to match some of the currency codes, and it couldn't find some of them, and so it was causing an exception to be thrown, which would cause our program to crash. Not so great. So what I decided to do was to come in and wrap this line 79 here, which assigns the culture, in a try-catch block. So now it's wrapped in this try-catch block that starts on 78 and goes to line 82, and to throw a new exception. So when your class fails, you may want to create your own custom exception class. And so what I did is I broke the rule I told you about, one class per file. I actually went down here to line 113, and I added a small little class. This is public class culture not found exception. I made up that name because it corresponds to the error that would happen in our program, culture not being found. And it inherits system.exception. So we're saying that it is a child class of the built-in system.exception class. And it's got one method, the new method, which creates a new instance of the exception, which takes two parameters, a message and an inner exception, and it passes them on to the parent class's new method, which takes the same parameters. So very simple class here, but we get to write our own message for it. And then so you can see here, I've used that up on line 81. Once I catch the exception, I throw a new culture not found exception, and I put the message in there, currency from the web service did not exist in Windows cultures. And so now my class will return a message if it doesn't find the cultures it's looking for. And then I can use that exception that's being thrown in my class in my form. This is the load event again, and this is the place where I tried to create the new currencies. And if it wasn't able to create one, it'll throw an exception here. I just put a little comment, said the currency didn't have a corresponding culture in the Windows environment. What this is going to end up doing is it's going to shorten the list of currencies that we can do conversions with. That may not be the behavior that you would want if you were building this, and you might come up with a sort of default culture to use in the event that the culture you're looking for isn't stored in the Windows library. But in my case, I just decided, hey, we don't. If they're not in the Windows library, then we just won't use them in our currency converter. Okay, so did that, and so now hopefully it'll work, and let's try to run it. And here it is. Here's our little currency converter application. You can see that it's gone out to the web and it's pulled down this list of currencies, quite a few of them. Why don't we select US dollar and then pick a target currency. I go to Japan a lot, so why don't I pick Japanese yen and select the amount I'm going to convert, let's say $100, and then click convert. And you can see that it goes out and it comes back and it says 8,179 yen, which is a completely pathetic exchange rate. In the toilet right now. I wish it would come back up so that I could get more yen for my dollars. If I wanted to change that to another currency, I'm going to Malta in the spring, so I could click euros, click convert. And you can see here that it changes 73,61, so it uses the European decimal separator and then the euro symbol. And you could do that for most any currency. Here you go, the Hungarian forint. How many of those can we get for $100? Wow, 19,894.59 forints, and apparently the symbol for forints is FT. So you can play with those all to your heart's delight. You can see how many Omani Rial could be. 100 Omani Rial is 51,000 forints apparently. Okay, so that is our currency converter class demonstration. We used a web service to get currency information from the web. We incorporated that into our own custom currency class, and then we used that class in a program to convert currencies. Hope this was helpful, and please ask questions and download the source code and read it if it'll help you out. Okay, in summary, understanding objects and classes is central to understanding object-oriented programming. Not all of your programs will require you to write your own classes, but many of them will help you out a lot if you can figure out how to do this. Most object-oriented programming languages, like Visual Basic, Java, etc., have extensive class libraries available to them, frequently referred to as APIs, or Application Programming Interfaces. In the case of Visual Basic, the API is known as the .NET Framework. And it's good to make use of those so that you can make your programming more efficient and more effective. But when the API is not sufficient, then you can always build your own classes. I hope you've gotten enough of an introduction here to be able to do some of this on your own. Good luck, and always feel free to ask questions.